Hi, Mike Johnson here, Department Manager in the Process and Electrical Department at Matrix Technologies, one of the largest multidiscipline engineering and system integration companies in North America. Currently, as a full-time Department Manager at Matrix, I work within our engineering division in the Power Instrumentation and Controls Department, where we maintain a dedicated staff of full-time electrical engineers. The primary responsibility of our division is to provide the highest level of engineering consulting services utilizing our team's vast background, knowledge, and experiences to successfully deliver projects on time, within budget, and at the highest level of quality our clients are accustomed to. One of the main industries of focus where our engineers spend most of their time is the process industries. Most process industries utilize automated and operator control systems to maintain and control their facilities. However, many process facilities often work with process materials and conditions that at times can cause significant hazards if not controlled properly. To help protect plants, personnel, the environment, and surrounding communities, many times facilities will implement safety instrumented systems. I'd like to take some time to look at and review, at a very high level, some of the major aspects of safety instrumented systems. Alright, so let's get started with some basics. As a good engineer would like to have it, there's a set of standards that help to define the rules and requirements for the design, implementation, operation, and maintenance of safety instrumented systems. Safety systems have a life cycle and cannot just be installed, turned on, and left to operate without any attention given to them. ISA 84 has adopted the ANSI IEC 61511 parts 1 through 3 as the standard for process safety systems. One aspect of the standard is that it is a performance standard and not a prescriptive standard. The standard is more qualitative than quantitative. And what this all means is that it gives a set of criteria and guidance, not necessarily a set value that is required to have a proper safety instrument system. Standards such as NFPA 86 or NFPA 87, those are more prescriptive based standards that state specifically how your system should look and what components it shall have and how it's meant to be installed. The Safety Instrumented System Standard gives a framework that allows each individual process facility to implement what they feel is an acceptable level of safety and risk for their facility. The standard helps to guide process facilities in designing safety instrumented systems. The standard helps guide plants through the major steps of PHAs, risk assessment, safety requirement specifications, SIL verifications, testing and maintenance procedures, and ultimately the decommissioning of systems. Okay, so that was a quick little run through the basics. Now let's talk for a moment about how the safety system operates at its most basic level. A safety system is meant to sit in the background and just monitor, not control a process. A safety system is meant to only operate when process variables move to outside of their normal operating ranges. In many cases, the goal of a safety system is to systematically and safely shut down a process unit, or in some cases, an entire facility. Safety systems utilize sensors and final elements, or instruments, and programmable automation controllers, safety PLCs, safety relays, to safely and reliably monitor processes and, when needed, bring it to a safe state. These devices are oftentimes designed and manufactured with a much higher reliability levels than normal devices used in main control systems. Many times these devices are required to allow the designers to obtain an appropriate SIL rating. With the advent of even smarter and more reliable instruments, many of these devices now provide data and diagnostics for themselves that even add to the level of maintenance and reliability that the devices have for their systems. It's also very important to remember that a safety instrumented system is not just a standalone safety system. Given the right design techniques and application of the standards, basic process control systems, or BPCSs, mechanical devices, and even operator interventions can also play a role in the overall safety system and protection of the plant. So, how good is a system, a safety system? Let's talk for a moment about the quality and reliability of a safety instrumented system. As design engineers, we can help guide our clients in making appropriate decisions for the design and implementation of their safety instrument system. However, it is imperative that as a plant and a company operating a plant, that you have a set standard on how you plan to design, implement, and operate your safety instrumented system. After the specifications are written, the appropriate SIFs identified, SIL calculations and verifications completed by a consulting engineer, the plant still has to own and maintain the system and the decisions that were made. It's imperative that a plant has a counterpart to the consulting engineer that is an expert in safety instrumented systems to help ensure that the system is designed, operated, and maintained as the company expects it to be. It is up to the plant to have individuals in all aspects of plant operations involved in making decisions on what is the best safety system for the plant. This includes, but is not limited to, engineering, operations, management, and safety. Every individual plays a role in safety for a plant. It's not just one individual or one firm that just sits there and makes all the decisions. It takes maintenance crews to properly test and document devices, management teams to make the right decisions and to protect the employees and the environment and their surrounding communities. As I mentioned before, safety systems are meant to not just be designed, installed, and left to operate. They need to be constantly attended to, maintained to ensure that when the time comes, they will operate as expected to properly protect the plant and individuals. Just as all of us go to the doctor for our annual well checks to make sure we're staying healthy, so too safety instrumented systems have to have their well checks to make sure that they're safe, that they're healthy. So I know this was a lot in a short little video, and there's so much more to it and beyond that. I hope you were able to gain some of the higher level expectations required to ensure that your facility is safely protected. One of the key takeaways I'd like for you to remember is that it truly takes a team approach to properly design, install, operate, and maintain a reliable safety instrumented system. It cannot just be one or two engineers crunching numbers and making decisions, but rather input, decisions, and follow through by everyone at your facility. Without that, the safety lifecycle will not succeed. If you're interested in checking out one of the many other articles that Matrix has published, you can head to our website at matrixti.com, or you can go to and then onto our Matrix on Manufacturing page. And also, if you'd like to learn more about safety instrument systems or any other services offered by Matrix, feel free to reach out to me directly, or you can, again, visit our website at matrixti.com. Thanks for watching. I hope you enjoyed this video, and I encourage you to browse our website and see what other interesting articles you may find.